Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So this is going to be a little bit of a different episode than usual, I think. Usually we kind of start off an episode going over some of the nerdy things that I was doing over the past week, and then we get into a lot broader of a topic or topics and cover that. Although this week, I think it's mostly going to be talking about nerdy stuff I did this week, partially because, not because there was a lot of stuff per se, but because I feel like there's a lot of lessons in there that we can really unpack and dive into, and really go deep into some software development, and then we can cover something else that I didn't necessarily want to talk about, but apparently I have to talk about it now. But anyway, we'll get to that here in the Dark Assassins podcast. But of course, as always, we have to start with, what nerdy stuff have I been up to this week? So this week, I actually found a pretty sweet deal on a network switch. So if you haven't been following the network switch market, I guess you could say, network switches are kind of expensive, as the whole chip shortage thing now. Getting a new network switch, or any network switch in general, is kind of harder to do, so prices are inflated. But I found a brand new sealed 24-port Netgear gigabit switch with 2 SFP gigabit ports and 2 SFP plus 10 gigabit ports for $60 on eBay. So I bought it. And it actually works pretty great. It's a fully managed switch. There's a ton of settings in the web UI that I haven't really gotten a chance to dig too deep into, but it has 10 gig Ethernet, which is very hype. I don't have any cables or network cards or anything like that to actually make use of it right now, but I at least have my foot in the door for 10 gigs. So soon we will have some 10 gig up in my homelab, and I am very excited for when that eventually happens, although it'll probably be a little while. But on to some other things. This week, like I mentioned, was fixing a lot of stuff that broke. Some of it wasn't my fault. Other things were my I'm and let's get into that. So one of the things that wasn't my fault that broke was, I'm pretty sure I mentioned on previous episodes of the Dark Assassins podcast that I basically wrote an API or a Python script to pull data from cpubenchmark.net, and basically to be able to format that into a CSV file so you can see a list of all, the various CPUs that you want to get information on. And I recently discovered a bug where, if, for example, one of the CPUs I was looking at didn't have a single-threaded score, so it was causing the program to crash. So I went and fixed that, and then literally a couple days later, I ran the program again, and I realized the clock speed, the turbo speed, and the TDP all were just showing up as NA. And I was like, what the heck? That's weird. Was it the update that I just pushed that's causing this issue? So I rolled back, but the NA problem was still there. And I was like, okay, so what the heck is going on? So then I went on to their website, pulled some of their pages, and looked through the HTML source code, and sure enough, they changed how the HTML was being displayed on their website, which is different from how I was trying to parse it. So I had to go and rewrite part of my parser in order to fix that. But it's working now, at least as of the recording of this podcast. I just pushed that update actually for it actually to work now right before I started recording this episode. So if anyone out there actually used this script and they noticed it wasn't working, if you go back to my GitHub, you should be able to download the latest and greatest, and it should be working for you. So, bug 1 fixed. And then as far as other bugs, last week I mentioned how I had a problem with this game that I'm trying to develop in C++, and how on certain compilers, well, all compilers it was compiling fine, but with certain compilers, when I would run the program, it would crash. And I said I couldn't figure out why, and I spent a lot of time trying to debug it and wasn't getting anywhere. But I figured it out. And I kind of want to walk through the process of how I determined what the issue was, my process for debugging it, so anyone out there that's having, problems with debugging might be able to kind of get a sense of, how I go about the process, and we'll dive into some concepts about the C and the C++ language as well. So basically, when I ran the program, it was always crashing at the exact same spot every single time, which is a good thing because, well, I guess it's not a good thing because it's crashing, but it's a good thing from the debugging perspective because you can easily narrow down exactly what's causing it to crash. Because if it's always crashing at a particular point, like in my case, when I would load into a scene, as soon as I would try to load into that scene, it would crash. So I know something to do with loading into that scene was the issue. So I was really able to narrow the scope of my entire code base down to a very small portion of the code base that I could dive into and figure out what the problem might be. So I had a general idea of where the code was crashing, and I also got an idea of what was causing the crash because I got the infamous segmentation fault. And if you're unfamiliar with what a segmentation fault is, it's basically notorious for like index out of bounds or array out of bounds, or basically you're trying to access memory that doesn't exist or you don't have access to. So think of it like you have an array of 5 elements and you try to access element number 7. That element obviously doesn't exist, so you're trying to access memory that you don't have access to, and the program crashes. So with these two things in mind, I had a really good idea of exactly the function, specifically what function was causing the issue. And the function that was causing the issue was how I'm currently dealing with reading in assets is I have essentially more or less a text file, although I basically created my own format for it for how to read data in. And basically what it's doing is I have a wrapper class that basically contains all of the structures or the structs for these different types of objects that are in this file, and then I read them in and parse them. So I was figuring somewhere in there I was having the issue. So I busted out my trusty debugger, the print statement, and got to work. Or I guess technically, since this is C++, it's the cout statement. But regardless, I got to work. Now, before we go any further, I have to say, if you're a software developer at all, I gotta say I can't personally recommend the print statement as your debugger. Yeah, it's down and dirty and it gets the job done, and that's generally why I go for it, because it's just quick and simple, and not always, but usually when I have issues that I need to debug, I just need to print out like one thing just to kind of see what the problem is, and a print statement's fine for that. But obviously the print statement isn't ideal. One, because you have to recompile your code every time you add a new print statement, and also depending on how many print statements you add, that can get very cluttered in your output. And then once you fix your issue, you have to make sure you remove all those print statements, and it can be kind of a hassle. So I would personally recommend actually using a debugger. I've used debuggers before. They are actually very helpful. Why I didn't actually use a debugger this time, largely I think it was because my main system that I develop on, which is a Mac, I wasn't having an issue on there, and I was developing, and I was trying to edit through Vim and the command line on the Linux system that was giving me the issues, and I didn't feel like having to navigate through GDB, which I've used GDB before, which is just a command line debugger, but I didn't feel like using it. But the nice thing about debuggers is they give you a lot more helpful information than a print statement, a lot easier. You don't have to recompile your code every time. And the other thing you can do is you can add breakpoints. And you can also, and with those breakpoints, it'll pause the program execution, so you can literally go into the system's memory and check, what variables are set to and what memory addresses are set where, and is super useful. So I highly recommend, if you don't actually use a debugger, to learn how to use a debugger and use a legit debugger rather than a print statement. But anyway, going on, so my initial guess was, I mentioned that I had a class that was basically a wrapper for my structs, and I was under the assumption that perhaps that class was not being initialized for some reason with certain compilers, but that wasn't the issue. Now, I've talked about structs a couple times, so for those who have not programmed, actually, let me back up a step first. So for all the non-software dev people, I know that whole thing about debuggers might have sounded like a bunch of gibberish, and basically what I'm going to talk about and discuss for the next, I don't know how many minutes, is probably going to start sounding like I'm talking in a foreign language, but if you bear with me, I'll try to make it make sense in the end. But with that out of the way, for those who haven't programmed in C before or don't know what a struct is, basically you can think of a struct like C's version of a class, but that's not a perfect one-to-one, comparison, mainly because the C programming language is not object-oriented like C++ and Java and Python are. So the idea of classes doesn't exist. So while I'm saying it's kind of like C's version of classes, it's not really, since there's no functions and all the variables inside it are public. So if you have, say, if you have like a bank account class or something, or I guess in this case, if you're using C, a bank account struct, you couldn't have a function like, bank account dot deposit funds or withdraw funds or something like that. You wouldn't be able to do that. You would have to create a separate function that would take in a struct, probably by reference, and then call it like withdraw funds. You pass in the struct by reference, and then it does the withdraw funds. So there is no functions. Everything is a public variable, so something to keep in mind there. And then the other thing, because structs aren't classes, you can't inherit from them. So another example with C and using structs, since it's not object-oriented and classes don't exist, but you'd still want to group things. So if we go back to one of I think it was probably the episode we did breaking down software development isn't black magic, we talked about the person class. So if you wanted to represent that in C, you'd basically make a struct for a person, and then you'd give them a char pointer, because strings don't exist in C. But, I mean, if you think about it, a char pointer or a character array is just simply an array of characters, which is really all a string is. So you'd basically have a character array for the person's name, then you have like an int for the age, and then anything else you wanted to represent for a generic person. However, unlike a C++, Java, or Python, where you could then inherit that person to some other class that's also a person, like we gave the software developer example where that was also a person, and they would have a name and an age as well, but also they would have an array of strings for what programming languages they know. Now, obviously in C, if you wanted to do that, you couldn't inherit from the person class, so you would have to create the software developer struct, and then you'd have to give them the name, age, and any other variables that were in the person, in addition to what programming languages they know. And obviously, because strings don't exist in C, you'd have to do a two-dimensional array of characters. So if you've never worked with 2D arrays before, there's a good example practice for you to do. Go into C and make an array of strings, which is essentially a two-dimensional array of characters. So the other thing, because you can't inherit structs in C, what this also prevents you from doing is in something like a C++ or a Java, let's say, if you create a person as the hierarchy class, and then you have your subsects like your software developer, teacher, nurse, doctor, whatever, you couldn't create an array of people that is essentially an array of persons, and then throw in that array like 3 software developers, a nurse, 2 doctors, and a teacher. You couldn't do that in C, because those are just completely different structs, and they are not the same, even though they kind of are the same. But because C is an object-oriented, you can't do that. So that's another limitation of C not being object-oriented. So now going back to my instance, so I'm using structs to represent these objects in the scene, mainly because I don't need a ton of data, and I don't want to create an entire class for something that's really small, so I decided to make structs. And the reason I'm using pointers, or essentially arrays, for these structs. And some of you might be asking, well, if you're having issues with memory allocation of these structs, why aren't you just using vectors? Because vectors are easier. Which, fair point. Vectors are generally easier. But the main reason I'm using pointers and arrays is mainly just out of personal preference. And also there is moderately a speed and efficiency advantage to it of using arrays and pointers versus using vectors, although realistically, in the grand scheme of things, with optimization turned on with the compiler, it's basically negligible. Now, why do I say that? Basically, arrays are not resizable. So if you create an array with 10 elements, that array will always have 10 elements, regardless if it's filled to the brim and all 10 elements are full, or if there's no elements in there, it always is set to 10 elements. And if you ever want to make that array bigger or smaller, the way you do that is you create a brand new array, and then you copy what data was in the old array into the new array, and then you would free the memory from that old array. So that's, quite the process. So generally, if you're making arrays, you don't want to resize them. You want to make sure that they're a fixed size and they don't change. But if you do have arrays that are not necessarily a fixed size and will change, that's where vectors come into play. Now, vectors are just arrays that you can resize. If you're coming from the Java world, you can think of this as an array list. It's basically the same thing, just C++'s version of an array list, more or less. But as we just established, if you want to resize an array, which vectors do, that's not free. There's stuff that's going on behind the scenes. So when you allocate memory for the vector, basically what the vector has to do is determine when to resize itself, to make sure that there's enough room for you to add stuff into it. Now, when you're and the reason why this isn't, necessarily a trivial task is when you're creating an array, the memory that array takes up is and has to be contiguous, meaning that all of the blocks of memory have to be in a row. So if you want to resize your array, you can't simply just tack on an extra, few chunks of memory at the end of your block, because that memory that you're adding might have been, other variables or system data or what have you, and that could cause a lot of bad things to happen. You don't want to do that. So the way that it works is when you request a new array or a new chunk of memory, basically what the operating system has to do is it has to go find a chunk of contiguous memory that's the size that you want, and then it assigns that to you. So then what you would have to do is you'd have to copy the data from your old chunk of memory into the new chunk and then free that old chunk. And the reason you have to free that old chunk is because if you don't, then that old chunk of memory is still allocated to the program. And then if you keep doing this process of getting new arrays and not freeing the old ones, you get what's called memory leaks. And if you leave this unaddressed, essentially what could happen is your program could take up all of your system's memory and completely make your system unusable. So you definitely don't want that to happen. Now, obviously, the solution for this is pretty easy. You just close out of the program and then all the memory is freed and then you're good to go. Or you could just use a programming language like Java that has garbage collection. And what garbage collection does is it detects when memory is no longer being used or addressed anymore and is able to retake that memory back to the operating system. In a nutshell, that's what it does. But in C and C++, there's no luxury of garbage collection. So you have to make sure that you're adequately managing your memory properly. Otherwise, you can get memory leaks, and that's not good. Now, realistically, even if you do have memory leaks, you're probably not going to take all of your system's memory up, partly because I doubt you would run your program long enough for that to be a factor. Plus, systems these days have so much memory comparatively to how much memory is used up by arrays, which we'll kind of get into some examples here in a little bit. But, back in the day, it was when systems didn't have a ton of memory, that was definitely a lot bigger of a concern. But obviously, still, you want to make sure that your software is free from memory leaks, since those are not good. So, with that said, so obviously, the thing with vectors is, while you can resize them, the thing is, if you're resizing a vector every single time you try to add a new element to it, you're definitely going to notice some slowdowns really quickly, because you have to go through the whole rigmarole process of asking the operating system for more memory, and then copying all your data to that new memory block every single time you increase your array size by 1. Obviously, if your array size is really small, like only 5, 6, 7 elements, that's probably not going to be that big of a deal. It won't be that big of a hit to performance. But if you're talking, thousands or tens of thousands or millions of elements, having to reallocate new memory and copy the old memory into the new memory every single time, that's really going to start bogging down your system. But the nice thing about vectors is they thought of this, so they don't reallocate themselves every time a new element's added. What they do is they'll say maybe allocate 10 elements, so then you can add 10 elements worry-free before it has to reallocate again. I'm obviously making those numbers up. But if you're actually curious on how it works, the way vectors actually calculate how much memory to allocate is the new capacity is equal to the old capacity times a factor. And that factor is generally 2. So what this means is if you have, say, a vector with a capacity of 4 elements, it takes that capacity and multiplies by 2. 4 times 2 is 8. So now your vector has a total capacity of 8. So if you had 4 elements and you added the 5th element and then it did that reallocation, so now it has 8. You currently have 5, so you can add elements 6, 7, and 8 before you'd have to, again, reallocate. So it grows in sizes of 1, 2, 4, 8, 16, 32, 64, etc. So the reason why this is good is it doesn't, right away off the bat, oh, this person needs more memory, here's 100 elements, and you only actually end up using 5, because then you'd be wasting a ton of extra memory. And the reason why I say it's good is because essentially this doubling aspect, the reason why this is good is because while obviously once you get to bigger numbers, you take up more memory, but you want to do the majority of your copying of data when you don't have much data to copy, because copying data, depending on how you're doing it, could take a while. Obviously, vectors are optimized, but for the sake of, argument here, if you say go one by one copying data, copying one by one of, say, 8 elements is going to be a heck of a lot quicker than copying, say, 1 million elements. So once you get to those bigger numbers, you want to have to copy that data less and less, which is what vectors were optimized to do. But obviously, like I mentioned, this does come at the cost of you're reserving memory that you're not using, which in the grand scheme of things, that's really not that big of a deal, because as we'll see, that amount of difference in data is kind of negligible. But if you get to like massive scales with like gigantic data sets or whatever, then it potentially could be cause for issue. But then again, if you're dealing with that big of data sets, you probably got tons and tons of RAM, so it's probably, again, not that big of an issue. Plus, vectors are just a lot more convenient than having to do all the resizing yourself. So yeah, if you ever have to potentially resize an array, you want to be using a vector. Don't use arrays. Don't make your life hard. So let's go to some examples here. So let's say that you have an array and a vector of integers. Now, integers take up 4 bytes worth of memory. So if you say have 100 integers, your array would take up 400 bytes, or just under half a kilobyte. And if worst case scenario, say the vector just reallocated itself and it now has double the space, so you have essentially 200 integers, even though you're only using 100 of those. Because how the vector has to do it is it has to allocate space for essentially 200 integers, so when you only have 100, you have space to allocate, 101, 102, 103, 104, and you don't have to worry about resizing the vector. Now, obviously, as we mentioned, this would never happen because of the whole doubling thing. If you actually had 100 integers in your vector, your total vector size would be more like 128. But just for the sake of argument here, and for easy numbers, we're just gonna say that it just doubled. So in this case, since you have 200 integers, even though you don't actually have 200 integers filled, you're taking up 200 integers worth of memory, which is 800 bytes, or just over 3/4 of a kilobyte. So realistically, what what the heck does this mean? Because, of course, on this show, we love context and perspective, so I'm going to give you some. So we're talking about an additional 400 bytes difference. So the array takes up 400 bytes and the vector takes up 800. So that's a difference in 400 bytes, which might sound significant, but if we actually look at, just a super basic bargain computer that has 8 gigabytes of RAM, I think 8 gigs of RAM is probably on the low side, but still fairly basic, I would say. So how significant is that? So for context, 1 gigabyte has 1 billion bytes. That's billion with a B. So there are 1 billion bytes in a gigabyte. So 400 bytes would occupy 0.00005% of your system's memory. So that's a 0 followed by 5 zeros, 5%. So essentially nothing. Virtually insignificant. So you add another 400 bytes on top of that, virtually insignificant. I mean, we got Chrome tabs that you open up 2 of them and you have no memory left. So using an extra 400 bytes, not really that big of an issue. So let's take a different example. Let's say that you're a baller and you make your own class, and your class takes up 500 bytes worth of memory, and you have a ton of these classes, and making it an array of, say, 10,000. So for similar numbers, we'll say the vector has the same amount, so the vector has 10,000, and we'll say worst case scenario, the vector just doubled, so the vector really is taking up 20,000 of these classes worth of memory, even though only 10,000 are actually allocated. Obviously, like we mentioned before with how the doubling works, this wouldn't actually happen. If you had 10,000 elements, you would realistically actually be at 16,384 for your total capacity. But again, for the sake of, easy numbers and simplicity, in a worst case scenario, we'll just say it doubled and you're at 20,000. So what does this look like? So in this case, the array would occupy 500,000 bytes, or about half a megabyte, and the vector, which is double that, would occupy 1 million bytes, or about a megabyte. So going back to our example with the computer with 8 gigs of RAM, we have half a megabyte would occupy 0.005% of your total memory, and 1 megabyte would occupy 0.01% of your total memory. So obviously a bigger difference than the 400 bytes, but again, still pretty darn insignificant in the grand scheme of things. And honestly, if you're getting to the point where the difference in your data the difference in the size of your data between an array versus a vector that just resized, if you're worrying about how much, memory difference is being taken up, you probably need to worry more about the processing power to copy all that data over to the vector and the speed performance rather than the amount of memory that's being allocated. So, I mean, again, we're talking 10,000 elements in this case, and it's still pretty darn insignificant. So you gotta be occupying a ton of memory and a ton of elements for there really to be any kind of appreciable difference between using an array and using a vector. So yeah. And honestly, like I said, with how optimized vectors are, with how it essentially doubles, continues to double, I mean, once you get to such large numbers, the times that you'll actually have to double becomes so infrequent that there's really not going to be much of a performance hit at all. So really, when it comes down to it, just use vectors if you need to resize your arrays. Now, if you're worried about, all the resizing of a vector that has to be done initially, like we mentioned, it goes from 1 to 2 to 4 to 8 to 16 to 32. If you're worried about how many times it's resizing itself, just like arrays, you can set the vector to be whatever size you want initially. And then once you use up that capacity, it will then go through the process of reallocating the memory to increase its size. So realistically, if you're worried about that, and say, for example, you're going to at minimum have 64 elements, you can set your vector to be size of 64, so you don't have to worry about the first 6 times that it's going to reallocate itself. You can essentially bypass that, which is, pretty nice. So if you have a minimum number, but it could be more than that, then that'd be, a time where you'd want to set your vector to that number, and you can grow that way. So at the end of the day, should you use vectors? As I've been kind of saying, unless you have a specific reason not to, I would go for it. Like I said, unless you know for a fact that you have a specific size that your array is always going to be, then just use a vector. Now, in my case, I said that I'm using pointers, which are essentially just arrays, for my structs rather than vectors, even though there's potentially a difference in size. So why am I doing that? Am I an idiot? Yes, but not in this case for the reason I'm going to get into. So while I'm not using vectors in the class, I am still using vectors in the function. And what I mean by this is when I'm initially reading the data in for the objects, I'm reading them into vectors because I have no idea how many of these objects I'm going to be reading in. So it doesn't make sense to have a pointer or an array and then have to constantly worry about resizing it. So that's why I'm using a vector to read the data in, and then once I have all the data read in, then I convert that data from a vector to a pointer. So it's always, because at that point, once the data is read in, I know it's going to be a fixed size for the duration of the run of the program. So I can essentially chop off all the extra memory that the vector might be taking off by storing it in a dedicated array. So that's the reason why I went that route. For essentially just the long-term storage. But another reason why I didn't go with the pointers and arrays when reading in the data is I definitely could have done that, but I would essentially have to read the data twice in order to know how big my arrays would have to be. So I'd essentially have to read in all the data, determine how big my arrays have to be, allocate that memory, and then parse through the entirety of the data again in order to read it in. And honestly, that's just way too much work and way too much overhead, and just dealing with vectors is obviously a lot simpler and probably even more performant too than having to read data twice before you can actually, parse it I guess not parse it, but you'd have to read the data twice before you can actually save it into your array rather than just dealing with vectors. So that's why I went with vectors there. So that was a incredibly long tangent, but hopefully you learned something about vectors and kind of how memory works with C and C++. So getting back to how I fixed the bug, so basically it turned out one of the structs that I had an STD string in it, or just a generic string in it. Now, for whatever reason, some compilers didn't care and they were able to allocate the data to the string no problem, and other compilers, they couldn't allocate the memory to the string, so when I'd try to set the string, I would be setting memory that didn't exist and it would crash. I'm not exactly sure why some compilers allowed it to work and others didn't, but basically the way that I ended up going about fixing this was saying, who needs strings? Let's go old school. Let's go back to the char pointers and allocate the memory myself. So basically that's what I did. I I switched the structs from strings to char pointers, and then in my function where I read in the data, once I got to the point where I'd have to read in the string, I would get the length of the string, and then I would allocate the char pointer accordingly to the right size, and then do a mem copy on that string to copy it into the char pointer. And then once I did that, everything worked just fine. So pays to go old school sometimes, I guess. Plus, anyway, I mean, strings are way too mainstream, right, guys? I mean, who uses strings? I mean, use char pointers, right? Go old school. Jokes aside, though. So basically, I told the compiler... So this is kind of what boggles my mind. So strings are supposed to dynamically allocate themselves, right? So why it happened where I told the compiler, hey, this is a string, and the compiler was like, okay, cool, and then when I went to go set the string, it didn't have the memory for it, and the compiler was like, nope, and the program crashed. Why that happened, I'm honestly not sure. So instead, I was like, to heck with you, compiler. I'm just going to do the setting the memory myself. And yeah, it worked. So cool, I guess. So yeah, that was the bug. For whatever reason, the compilers didn't like the fact I was trying to set strings, so I just converted to char pointers, and everything started working. Now, for all of you that just heard me speaking in a foreign language for the past, I don't know, how long it's been, 30 minutes, something like that. Let me try to summarize this in a manner that might hopefully allow you to kind of understand what's happening. So basically, let's just say that I had an array of 3 elements, and I was trying to add data to elements 5, 6, and 7. Obviously, I'm not allowed to do that because the array is only a size of 3 elements. So essentially what happened was the compiler gave me an array of 3 elements when I was expecting it to give me an array of 7 elements. So I was assuming that I had an array of 7 elements so I could set elements 5, 6, and 7, when in reality I only had an array of 3 elements, and trying to set elements 5, 6, and 7 caused the program to crash. So my solution to this was to say, no compiler, I'm actually setting this array myself so I know that it's big enough. This is an array of 7 elements. So then, because I manually set that myself, I was able to then go ahead and set elements 5, 6, and 7, and it worked just fine, didn't crash. Now, yes, software developers, I know it's really indexes 4, 5, and 6 because we start counting at 0. But elements 5, 6, and 7, if you talk to someone that doesn't know programming and you say, I have an array of 7 elements, and then you say, but I only am able to set to element 6, or, sub 6, they're going to act confused because they don't understand that we start counting at 0. So that's why I said 5, 6, and 7. Yes, I know it's really 4, 5, 6, whatever. So that was that bug. So some other things that I broke. So a while back, I don't remember if I mentioned it on the podcast or not, but a while back, I had, in my Dell R620, I upgraded the CPUs in there. And for whatever reason, when I did the CPU upgrade, not all my RAM was being detected. And that was a real big bummer. And I couldn't figure out why the RAM wasn't being detected. So eventually after, I don't know, it was hours of troubleshooting. I just said, to heck with this. I'm just going to try to minimize my losses and move some RAM around so I mitigate how much RAM isn't being detected, and just called it a day. Well, this past week, I was doing some maintenance on my servers, moving things around in the rack, as you do. And I figured, I have the server powered down, everything's out of the rack, might as well pop it open, see if we can't, figure out this issue. Now, I can't remember where I heard this from, But I remember hearing, after the initial incident of the RAM not being detected, I remember hearing somewhere that if you don't have perfect contact with the CPU pins, you could potentially run into issues with like PCI cards or RAM not being detected. So I remembered that, and I figured, you know what? Let's just pop the CPU out and see if there's anything going up with these pins. So pop the lid off, unscrew the heatsink, pop the CPU out, and wouldn't you know it, there's some dust on those CPU pins. And I was like, this is probably the issue. So I go grab a can of compressed air, blow that dust out, put the CPU back in, put the heatsink back on, put the case back, put the lid back on, fire the thing back up, and voila, just like that, all the RAM's detected again. So yeah, if you ever, I guess the moral of the story here is if you're ever either upgrading or installing a CPU, make sure the pins are clean, there's no dust there. And if you have any issues with, PCIe cards or RAM modules or anything not being detected by the system or whatever, check the CPU. That might be the issue. Might have some issue with the connection of the pins. Now, another thing that I wanted to address also that has been kind of giving me some issues recently was desktop computers not booting when they run headless. Now, essentially what that means is when we say run headless, that essentially means that there's no monitor plugged into it. Now, I've talked before on the podcast about how great old desktops are as servers because they're pretty cheap. But one thing you have to keep in mind is I've had this issue with some, but not all, where if I run the computer headless, it just won't boot for whatever reason. It needs to have a monitor plugged in. However, the nice thing is there's a pretty cheap and easy fix for this. Basically, what you can do is you can buy these like dummy connectors, and you can get them in all kinds of connectors. You can get them in like DisplayPort, HDMI, DVI, VGA. I mean, basically any connector you can think of, you can probably find a dummy connector for it. And I mean, you can pick them up for like under $10 on Amazon. It's pretty cheap, and you just plug that into your display output, and it boots just fine, no issues. So pretty easy fix. So for anyone out there that if you ever run into an issue where you have an old desktop you're using as a server and it's not booting, that could potentially be an issue. If you notice that when you have a monitor plugged in, it boots just fine, but then when you try to boot it headless, it doesn't work, that's probably your issue. But like I mentioned, it's really weird because some desktops have this issue and others don't. Now, I have one of my desktops is a Dell Optiplex 7010. Now, this thing has an RX 550 in it, so it has a dedicated GPU. So this really doesn't like the fact that no monitor's plugged in, so I have to plug one of those dummy connectors in. But I didn't want to plug it directly into the graphics card because I wanted to pass the graphics card through to a virtual machine. So I had to plug the display connector into the onboard graphics. But the problem with that is the BIOS by default goes to the dedicated graphics card, so it still wouldn't boot. So basically what I had to do was I had to manually go into the BIOS, force it to go integrated graphics, power the machine off, unplug the monitor, plug the dummy connector in to the onboard graphics, and then boot it back up, and it worked fine. But if I ever unplug that dummy connector, it defaults back to the dedicated graphics and I have to go through this whole process again. So I just essentially never unplug that dummy connector now. It just always stays in the system. Now, another issue that I had recently was I have an HP Elite Desk also that I've been using as a router. So obviously this doesn't have a dedicated graphics card in it, but I've been having some like on and off issues where sometimes it will refuse to boot if there's no monitor plugged in, and other times it boots just fine. I have no idea why. Part of me is thinking I'll end up probably getting one of these dummy connectors for it anyway, but I haven't done that right now. But also, I was doing some other experimenting with it, and I noticed that it was, for whatever reason, it was like kernel panicking and crashing with like the Ethernet card that I had in it. So basically, I think I might have fixed it, which was basically editing the grub config file, which if you've done any kind of like PCIe pass-through, you generally have to edit your grub config file, especially for like graphics cards. So I did an edit for that, and so far, fingers crossed, I haven't had any issues with it since. So I'm wondering if that was part of the issue why it was crashing like in the middle of running and sometimes not even booting. So I'm hoping that might have been the issue. I guess I'll find out here if I have any additional issues with it, but I guess we'll see. But then on the flip side, another desktop I have a ton of computers, is a Dell Optiplex 550 Micro, and that thing works like a charm. It works like a champ. No issues at all, whether a monitor's plugged in or not, boots without issue. So your mileage may vary on desktops as far as if they work or don't work running headless, but if you have any issues running them headless, my recommendation is first plug in a monitor and try to boot it. If it boots just fine but doesn't boot, if you don't have a monitor plugged in, just buy one of those cheap dummy dongles. Well, I guess it's not really a dongle, it's just like a little dummy connector that plugs in, and your issue will most likely be resolved. But all of this to say, lots of bug fixes, lots of tinkering, lots of, messing around with stuff. And really, I guess at the crux of it, that's kind of, the point of having a home lab and doing personal software development projects, right? It's all about tinkering, breaking things, fixing the things that you broke, and all the learning in the process that goes into that of figuring out why it broke, what broke, how you fix it, all part of the learning process. So quick aside to all the colleges and universities out there that say I do not enjoy learning, as anyone that listens to this podcast can clearly see, I actually do enjoy learning quite a bit. However, the exquisitely abhorrent and archaic manner in which these colleges and universities perpetuate learning through the use of such archaic methods of reading textbooks and taking exams, it's quite simply atrociously flagitious. But before I go and get on my soapbox here and go on some tirade about my complete and utter disdain for school, I'm just not even going to start there, and I'm just going to leave with what I just said. Also, props to thesaurus.com for allowing me to succinctly and condensedly express my opinions on the subject in such a concise manner. So shout out to them. So I also, if you really want to hear me go on tirades and rants about school and how much I hate them, I did a whole episode a few episodes back on are advanced degrees worth it for software developers? Spoiler alert, they're not. But if you want to hear more ranting, by all means, you can go and listen to that episode. Now, we're kind of running out of time here, but real quickly, this is a topic that I honestly didn't want to cover, and honestly, with how late we are into the episode, I could probably just skip it, but I'm not going to do that. So, if you didn't know, last week, Apple released some new iPads. Now, obviously, I didn't talk about them. Personally, I thought the conversation that we had last week about all the networking stuff was way more interesting and way more productive, because personally, that they honestly just, all they did was do a press release, and quite honestly, I thought it was a snooze fest and didn't think it was even worth covering. But apparently, there's been a lot of drama on the subject, so I figured we probably should at least kind of talk about it to see if any of this drama is justified. So let's just run over a quick look at the specs here. So they released two new iPads. They released a base model and a new iPad Pro. Now, the base model is basically the iPad Air 4th gen, or the iPad Air before it got the M1 chip, but with some interesting improvements and kneecaps all at the same time. So like the iPad Air 4th gen, it has the A14 in it, and it has the same design language, the same, slim bezels all around, same display size, that kind of thing. But unlike the iPad Air 4th Gen, this is kind of where it gets kneecapped. It only supports the Apple Pencil 1 for some reason, even though it has USB-C. Why? I don't know. It doesn't have a laminated display because reasons. That Magic Keyboard folio case that the iPad Air and the iPad Pros have, this doesn't have support for that, in favor of a new Magic Keyboard case that only supports this new iPad. It has 5G capability rather than 4G. It's so weird because, like, in some aspects, it's an improvement. And one of the other improvements that people have been talking about is the webcam has been moved to the landscape orientation. So if you have your iPad in landscape on, like, say, a FaceTime call, you're actually looking into the camera rather than that weird, like, it's kind of off to the side type thing. But it's just weird that they have this, like, they gave it improvements while also kneecapping it at the same time. Also, the price of the base model iPad is now $449 for the 10th Gen one, although I should mention they still are offering the 9th Gen iPad for $399. Yeah, so that's kind of weird. The iPad Pro is essentially a snooze fest. It has the M2 chip because obviously the M1 chip wasn't powerful enough in an iPad. That's sarcasm, by the way. Honestly, the M1 chip was already overkill in an iPad. So now moving up to an M2 chip, that's just, I don't know what you're going to do with that. Now, there's also hover support for the Apple Pencil. So basically, you can hover the pencil over the iPad's display, and it'll kind of give you kind of an indication of what the pencil is. So if, like, you're drawing, for example, it can kind of show you the size of the stencil you're using. So I guess that's pretty cool. But from what I've understood, this seems just to be a software thing. It has nothing to do with the hardware of the iPad Pro, yet it's only coming to this new one. So that's kind of interesting. You can record in ProRes now on the iPad Pro because obviously everyone with an iPad Pro, that was the one feature that they were like, man, this iPad is really lacking the ability to shoot in ProRes, and that's the one thing that I need, is to be able to shoot in ProRes. Again, I'm being sarcastic here. God, this is so, I don't understand, like, honestly, I can't think of anyone that like is actively taking photos and, like, recording video with this chunky iPad rather than, like, just their phone or, like, a dedicated camera. And I don't know. This is why I thought it was a snooze fest. Like, it's not interesting. And it got Wi-Fi 6E, Bluetooth 5.3 support, and that's it. Like, but the thing that's weird is, so the iPad base model got the camera moved to the horizontal position, but the iPad Pro didn't. So I don't know what's up with that. So some of the drama regarding this was the fact, going back to the base model of the iPad, was the fact that it got a different Magic Keyboard than the one that's supported for the iPad Air and the iPad Pro. Now, personally, I understand it would be nice if there was support across the board for the same keyboard cases. Although one of the arguments I heard was, like, if you already have, one of these other iPads, you can't use your keyboard case with this new base model iPad. And I just kind of rolled my eyes because I'm thinking here, who in their right mind and what normal person in general has, one of the higher end iPads that uses, this keyboard case and is also wanting to buy or upgrade or whatever to this base model iPad and get the keyboard case. Like, I can't think of that. I can't imagine that market is very big. So I feel like that, whole, commotion and uproar over that is kind of, there's not much weight to it because the people that would even be affected by that are very slim, if there's any. Now, some of the stuff that is justified, the fact that it doesn't support the 2nd Gen Apple Pencil is kind of dumb to me. I mean, it has USB-C, and the Apple Pencil 1 uses Lightning to charge. And the way the Apple Pencil charges is by plugging into the Lightning port on the iPad, which this new iPad doesn't have. So yeah, Apple had an ingenious solution. Basically what they're doing is they're including a female-to-female USB-C to Lightning dongle. So what you do is you plug the Apple Pencil into the one side of this dongle, and then you plug a USB-C cable from your iPad into the other side of the dongle, so you have this thing to charge your pencil. It's a interesting solution. So I think that's kind of justified. Now, I did hear one argument of why they're still supporting the first-gen Apple Pencil, and that was because, like, the education market had a ton of the base model iPads, so this way they wouldn't have to upgrade all their Apple Pencils. Like, I guess, but, like, honestly, realistically, how hard would it be for Apple to support both the Gen 1 and the Gen 2 Apple Pencil? Like, realistically, I don't think it should be that complicated to be able to support both of them. Like, I get from, like, you know, the perspective of the Apple Pencil, like how they charge, you know, that's kind of different in support. But as far as, like, the actual mechanism of the pencil being able to write and, you know, interact with the display, I don't understand why this is an issue. Maybe, who knows, maybe it has to be with the fact that for whatever reason, the base model iPad doesn't have a laminated display. And basically what that means is there's like a little air gap between the actual display and the glass of the actual screen, so if you're wondering what that means. But yeah, the iPad, the new base model iPad is just, it's just weird. So I guess in some regards the drama is justified, but I think it's generally just overblown in the grand scheme of things. But it is just a really weird decision by Apple to essentially give it, like, make it better in some regards than other iPads, and also, like, kneecap it in others. So it's weird. I don't know. And then the iPad Pro, I mean, that's just way overkill for a device that was already way overkill with the M1. So yeah, iPads are weird. Yeah, I don't really have much else to say on them, and we're already way over because of this iPad talk. So I'm just gonna leave it there for this episode. So if you enjoyed it, I ask that you leave a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member who would be interested in, you know, maybe learning about some of the dirty, nitty-gritty details of C++ memory and arrays and vectors and all that good stuff that we talked about on this episode. And if you have any questions, feel free to shoot me an email at contact@darkassassinsinc.com. Whether you have questions about this episode, you have topics that you want me to address in future episodes, shoot me an email. Link is in the description below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action, not equal to null, return true. I'll see you next time on the Dark Assassins podcast.